In today's video, we're going to look at section 7.2, frequency and probability distribution. I want to look at what each of these things are and relate them to a histogram that we looked at in the last section. So, first of all, I'm going to look at this example. And we are looking at a car dealership here. Dealership A and dealership B. And we want to know which dealership is best to buy a car from. So, which dealership has the most weekly sales overall? The problem is dealership A has given us the information for car sales for the last year. Dealership B has given us the information for the last 2 years. So we just know what their weekly sales are. But we've got them for 2 different periods of time. So it's difficult to compare the two. That's where relative frequency comes in. We're going to look at, relative to the whole, how many sales did they have? What percentage of the time did they have a certain number of sales? That's what we're going to be looking at here. So we're looking at, with relative frequency, it's the frequency of something happening in comparison to the total. Okay, so here we've got the number of weekly sales being 5, 6, 7, 8, 9, 10. And we know that for 2 weeks of the year, dealership A had 5 weekly sales. And we know that over 2 years, there were 20 weeks where dealership B had 5 weekly sales. Remember, dealership A gave us the information for 1 year. Dealership B gave us the information for 2 years. So we know that there were 20 weeks out of 2 years where dealership B had 5 weekly sales. Okay. So in order to find the relative frequency, that's where table 2 comes in. We've taken each of the frequencies, so the frequency that something happened, and then divided it by the total number of weeks. Okay, so you should see here that if we added all of these values together, we should get 52, the 52 weeks in a year. If we add all of these together, because that is 2 years worth of information, we should get 104. Okay, and that's exactly what you get. So what we do to find the relative frequency, so the frequency of something happening relative to the total number that we have, is for dealership A, for 5 weekly sales, happened 2 out of 52 weeks. So that was 4% of the time, 0.04. Okay. Then let's go over to dealership B. For 20 weeks out of the 104 weeks that we have in 2 years, 20 out of 104 was 19%, 0.19, okay? So 19% of the time, dealership B had 5 weekly sales, okay? So that helps us compare what's going on. So that is why we like relative frequency, because it compares the frequency of something happening in comparison to the total number of things that have happened. So it really helps with this comparison. This tabulation that we have here, where we've got the 2 tables, where you start out with, in this case it's weekly sales, so you're looking at the things that can possibly happen, your outcomes. Okay, you've got the outcomes on one column, then you've got the frequency on another column. So for this first table, we've got the outcomes on the first column, and then we've got the frequency of each of those outcomes on the next 2 columns. Okay. If you also add in the relative frequency, you can add that as a separate column as well. We've done them as 2 different tables here just because there is a lot of data, but you can add that in to the same table. These tables are called a frequency distribution and relative frequency distribution, respectively. So here we have a frequency distribution table. Okay, and a relative frequency distribution. That's what these tables are referred to as. Okay. So whenever you get one of these problems and they ask you for a frequency distribution or a relative frequency distribution, all I want you to do is take the information that they've given you, put the outcomes in one column. Then if they just want the frequency distribution, you just list the frequencies of each of those outcomes. Okay, so how many times each of the outcomes happened. If they ask for a relative frequency distribution, you have to go a step further. You have to divide each of the frequencies by the total number that we have. Okay, so you add together all of the frequencies, that should give you a value n, and then you divide each of those frequencies by n. So let's say you had, we'll call the frequencies F1, F2, F3, F4, etc. Then in order to find the relative frequency, you add together all of your frequencies for that column. Okay, so add together the whole column. That will give you a value n. And then for the relative frequency distribution, you just take each of those frequencies and divide it by the total number. Okay. What we have here is a histogram representing the data that we have. This is useful because just like in our previous section in 7.1, it helps us to visualize this data and see exactly what's occurring, because it's great to have all these numbers in a table and to see what's happening, but to actually see the data and to kind of get more of an idea of what's going on. Same with what we did in 7.1 with histograms and box plots. It really helps us see where the data lies. So that's why we like to draw histograms whenever we've got any kind of frequency distribution. So what they've done here is they've taken each of the outcomes and they've figured out its relative frequency. Okay, so exactly what we did back in table 2 here, they figured out the relative frequency of each one. Then what they've done is they've done one notch for each of the outcomes. So we've got a notch for 5, 6, 7, 8, 9, 10 and 11. And then they've drawn a bar that goes up to whatever its relative frequency was. So for dealership A, we said that for 5 weekly sales, there was a 4% chance. So you'll go up to 0.04, okay, because 4% of the time they had 5 weekly sales. And we said that for dealership B, 0.19 was the relative frequency of 5 weekly sales. So 19% of the time, dealership B had 5 weekly sales. So we've gone up to 0.19 for the histogram and dealership B for the outcome of 5. Okay, so you do this for each one and you draw a bar for each one, and that will give you the histogram for your data. So again, we've done this for both of them because it helps us to compare what's going on. We can see here from just visualizing the data, dealership A tends to have more consistent sales. Okay, the majority of the time we're looking at 7, 8 or 9 weekly sales. Okay, that's kind of where the majority of their data lies, is through here. With dealership B, they have a lot more high weekly sales, but to compensate for that, we also see that they have a lot more weeks with lower weekly sales. So we can kind of figure out which dealership we would like to go with. Yes, dealership A is more consistent. Dealership B, they have a lot more weeks with higher weekly sales. But on the flip side to that, compared to dealership A, they also have a lot more weeks with lower weekly sales. So we can kind of figure out with this risk which one we would like to go with. That's why these histograms are so useful, because it helps us to compare that data. Kind of carrying on with this theme of histograms, there's another thing that we can also do in order to figure out which one we would like to go with. And that is figure out probabilities. We've kind of touched on this already, but I want to actually see how we figure out probabilities given these relative frequency distributions and histograms. Okay. Let's say I want to figure out for each dealership the probability of having 7, 8, or 9 sales in a week. Okay. So what I'm going to do, if I want to figure out the probability of 7, 8, or 9, okay, what I want you to do is to add together the areas of the rectangles corresponding to those outcomes. Okay, so you can see that each one of these bars in my histogram has length 1. Okay, and the height of it is the relative frequency. So it's the probability, if we multiply 1 by that relative frequency, in this case, because you only have a bar of width 1, it works out. But it's going to be 1 multiplied by the relative frequency. The relative frequency in this case is going to be the probability that that outcome happens because it has width 1. You always do this with histograms. Most of the time you're going to be dealing with bars that have width 1 anyway, and then you add them together. But with more complicated cases, you would multiply the width of the bar times how high the bar is. And remember, the height of the bar is the relative frequency. Okay, but like I said, for the majority of the examples that you're going to deal with, it's going to have a bar of width 1. So the probability of that outcome happening is just going to be the relative frequency. Okay, so the probability of 7, 8, or 9 happening, if we go back to our relative frequency distribution, because this is slightly more accurate, you can see it more here as opposed to the histogram, we would add together the relative frequencies of each of these. So it's going to be 0.25 plus 0.38 plus 0.19. Okay. So if you add all of those together, you get 0.82. Okay. So 82% of the time, dealership A has 7, 8, or 9 weekly sales. Okay. You could do the same for dealership B. So what's the probability that they have 7, 8, or 9 weekly sales? Well, you add together each of these. Again, because each of those bars has width 1, we don't have to worry about multiplying the width by the relative frequency. But if the bar had a larger or smaller width, then we would have to worry about multiplying the width by the height. Okay, but in this case, we just add them together. So the probability of 7, 8, or 9 weekly sales for dealership B is going to be 0 plus 0.1 plus 0.12. Okay, so only 22% of the time does dealership B have 7, 8, or 9 weekly sales. So again, that helps us kind of compare. If we're looking at this and comparing two different things, it does help us figure it out, as we can look at probabilities for each one and compare them. But as a general rule, we'll write this here, in a histogram, the probability of an event E is the sum of the areas of the rectangles corresponding to the outcomes. The next thing I want to look at is something called a probability distribution. This is very similar to a frequency and relative frequency distribution, more similar to a relative frequency distribution actually. Because what we're going to have is, again, a table where we've got our outcomes on the first column, and this time is going to be the probabilities of each of our outcomes on the second column. The difference between the two is that with our relative frequency distributions, they were for actual experiments that had taken place. Okay, so with our previous example, we were looking at car dealerships and we looked at their sales. That was taking actual data and looking at, okay, what was the frequency of each one? What was the relative frequency of each outcome? Okay, that's what we had with our first example. With a probability distribution, we're saying, okay, we haven't conducted the experiment yet, but theoretically, this is what we expect the probabilities of each of the outcomes to be. So the first example, we actually took an experiment and figured out the relative frequency of each one. We saw exactly what happened. With a probability distribution, we're saying, okay, we haven't conducted the experiment, but this is what we expect to see theoretically. Okay, so that's the difference between the two. Is one is for real data, the other one is what we expect to happen in a theoretical example. Classic example with a probability distribution is saying, hey, we're going to toss a coin and heads or tails. What's the probability of getting heads or tails a certain number of times? Okay, so what I'm going to look at here is looking at tossing a coin 5 times. Okay, so we're going to toss a coin 5 times, and we're going to look at the number of heads that we get from tossing a coin 5 times. Okay. So I already know my outcomes, my possible outcomes for the number of heads. Well, I can have no heads out of the 5 tosses of the coin. I could have 1, I could have 2, I could have 3, 4, or 5. Okay, can't have any more than 5 because I'm only tossing the coin 5 times. So the maximum number of heads that I could get is going to be 5, and the minimum I could get is 0 if I got all 5 tails. Now, what's the probability of each one? Well, first let's look at the total number of possible outcomes that we can have. Okay, if we are tossing a coin 5 times, then there are 2 possibilities each time you toss the coin, heads or tails. So from tossing the coin 5 times, we know that there are 2 to the 5 possible different outcomes that we can have in terms of sequences of heads or tails. Okay, so there's 2 different outcomes, heads or tails, and we are tossing this coin 5 times. So that tells me that there are 2 to the 5 different sequences of outcomes that we can have here. So there's 32 possible ways that you can get heads or tails from tossing a coin 5 times. Okay, so I know that I have 32 different sequences of heads or tails here. Okay, so I could have heads, heads, tails, tails, heads. That would be one particular sequence. There's 32 different sequences of heads and tails that I can have here from tossing a coin 5 times. Now I want to know what's the probability of having 0, 1, 2, 3, 4, or 5 heads out of the 32 different sequences of heads or tails. Okay. If I toss a coin 5 times, okay, the number of ways that I can have 0 heads would be looking at the combination that out of 5 tosses, I have 0 heads. Okay. If you type that into a calculator, you would get 1. Okay. So that tells me that the probability of having 0 heads with 5 tosses of a coin would be 1 out of the 32 different sequences of heads or tails. Okay. Now I look at if I'm doing a combination of 5 tosses of a coin and I have 1 head. Okay. That gives me 5 different ways that I can have 1 head out of 5 tosses of a coin. Okay, so that tells me that 5 out of 32 of my sequences are going to have 1 head. I keep going with this, okay? Out of 5 tosses of a coin, the number of ways that I can have 2 heads is going to be 10. The number of ways that I can have 3 heads is also going to be 10. Number of ways that I can have 4 heads is 5. And the number of ways that I can have 5 heads, well, out of 5 tosses of a coin, there's just going to be 1 way that you can get that. Okay, same as having 0 heads, that would mean that you had all tails, and that's just 1 sequence where you had the 5 tails. So that tells me what each of these probabilities are going to be. Okay, so the probability of having no heads from 5 tosses of a coin is 1 out of 32. There were 32 different sequences of heads and tails, and 1 out of 32 of those sequences has no heads. That would be where I had tails, 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 tails. Okay, so all 5 were tails. Out of the 32 different sequences of heads and tails, 5 out of the 32 sequences have exactly 1 head. So the probability of getting 1 head and therefore 4 tails is going to be 5 out of 32. And you carry on with this, okay, with each outcome. This is a probability distribution table. You don't necessarily need this part in the middle. I just did that to show you where each one comes from. But it would give you each of the outcomes and their probabilities. This is the histogram that represents that data. Okay. Same thing happens as we had with our previous example. If I want to find the probability of some outcome, so let's say the probability that there are 3 or more heads that are thrown out of the 5 tosses of the coin, I would look at what the area was of the rectangles that represent those outcomes. So the probability of the event of having 3 or more heads would be the probability that I had 3, 4, or 5 heads. So I just add together the areas for those particular outcomes. Again, each one of these has a width of 1, so figuring out the area of that rectangle is easy. It's just going to be the height. But that's all you do. It's exactly the same as the last problem. So once you have this histogram, it's easy to see what's going on. And you can also pick these values off of the probability distribution table, especially if the histogram is not that accurate. Sometimes it can be easier just to do it straight off of the probability distribution table. But in terms of the histogram, that's exactly what you do. You just add together the areas of each of the rectangles representing the outcomes that you're looking at. In the next video, we're going to look at more of this probability distribution stuff. And we're also going to introduce something called random variables. So that will be the second half of 7.2.